It is time for deep learning. This is what we're all here for. Let's jump right in. Here is a nice Venn diagram of deep learning. Let's start at the outermost circle with artificial intelligence. It says mimicking the intelligence or behavioral patterns of humans or any other living entity. Personally, I think of artificial intelligence as including the physical device. So it could be the robot itself, the self-driving car. And there's a lot that goes into that. I also like to think of artificial intelligence as better named collective intelligence because really the intelligence that goes into it is like the collective human intelligence. There's really a lot. It's made by humans, okay? Anyway, in the second circle from the outside, you see machine learning, a technique by which a computer can learn from data without using a complex set of different rules. This approach is mainly based on training a model from data sets. So you all have a working understanding of how that works. I think of machine learning as the code behind artificial intelligence. And in particular, for me, it's something that I do in the sense of I write machine learning models. So when you're on the side of doing it, it's not this like abstract thing like, oh, what is machine learning? It's code. It's Python code that makes predictions from data. And the learning part is based on learning from new data. Then within that, we have today's focus, deep learning, a technique to perform machine learning inspired by our brain's own network of neurons. Now, this is actually pretty interesting. The first machine learning models built in the 50s were actually neural networks like the perceptron. They were based on deep learning. There were some issues early on. We didn't have the computing power, so it wasn't until like around 2000, and then even in more particular in the last 10 years, like the 2010s, where deep learning, say, really took off. In I would say with and beyond machine learning. Okay, deep learning greater than machine learning, arguably. Why? Well, deep learning is more mathematically intricate, as we will see. Deep learning performs better with unstructured data like text and images and video, which is a big part of what's being done in the world today. Deep learning performs better in very large data sets, billions of entries or more. And deep learning is at the cutting edge of many AI technologies in industry like robots, digital assistants, kind of like Alexa and Siri, and self-driving cars. Okay, here's a picture of a deep learning network. Now, I think before getting a sense of what's going on in this network, allow me to suggest what the network would look like if it wasn't deep learning, okay, if it's just regular machine learning. What you could do then, you can take out the hidden layer in the middle. Imagine it's gone, okay? On the left side, you have input. What is that? That's like one row with 3 columns of data, okay? And then on the right side, you have output. And these are 2 possible outputs, perhaps 0 and 1. So each of those inputs is going to be multiplied by a number, and they're going to go to the different outputs. So if you take like the first blue node at the top, it would actually have 2 arrows going from it, and it would go to both of the outputs. That would be the same with the other blue nodes. And so when you get to the output, you would be able to trace back 3 different arrows going to each of the different inputs. So in effect, you would sum up the weights, okay? So the arrows are going to bring weights from the inputs to the outputs, and then they're summed up. So at the very end, the output should be something like, say, 0.72 at the top and 0.28 at the bottom. So the result is 1 because there's a 72% probability of 1 and a 28% probability of 0, for instance. Okay? That's the way it would have to be. Now, deep learning differs by adding hidden layers. Okay, here's one hidden layer of 5 nodes. And as you can see, it makes this model much more mathematically intricate. There's just a lot more arrows. There's a lot more combinations of weights going on. And you can really just do a lot more with it. Okay, so the weights are now combining to go to the hidden layer. And the hidden layer is doing its own little weight manipulation to go to the outputs. Okay. As another example, let's take a look at this one. you can see how sophisticated it can get. So here on the left side, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes. So let's say you have 10 different columns in your machine learning, or I should say in your data set. And at the far right, we have one output. So this appears to be a regression deep learning model. All nodes are combining to deliver one number, which is some kind of an output. And you can see like there's just so many lines here because it quickly gets complicated and complex. And so deep learning models are able to pick up on great intricacies within the data. This one in particular has 1, 2, 3, 4 hidden layers in the middle. Now, at one time, this was considered an optimal deep learning structure. It's a pyramid structure where you have a less number of layers each time. Now, if you start with 100 nodes there, it's not saying go 99, 98, and so on. Maybe 80, 60, 40, 20, for instance. However, research has shown, research actually tends to show both ways. There's not a lot of definitive results here. You kind of have to experiment. That also having like several hidden layers of the same length, meaning the same number of nodes, can produce optimal results. So again, this was a leading strategy in the past. These days, it's still like a great one, but I think you just want to experiment with your hidden nodes, which we will do a lot of this week. Okay, now let's talk about Keras. Okay, so what is Keras? Keras is a high-level API based on Google's TensorFlow. It is Google's TensorFlow. It's just a user-friendly version of it that pretty much everybody's using today. Many deep learning models used in production use TensorFlow. Okay? Most deep learning models and structures can be built using Keras. For this class, Keras will be sufficient. For most real-world problems, Keras is actually sufficient. So when you're just getting started, pretty much everybody uses Keras. Okay, TensorFlow just has more, and it's not necessarily better for more in this sense, right? TensorFlow is something that it just has additions. So if you were pushing like what you wanted to do to edges and Keras didn't quite have what you were looking for, then it's time to use TensorFlow. Okay, until then, Keras will be fine. So we will learn the ins and outs of Keras in this class. Starting today. Starting right now. Let's do it in the notebooks.